Hey guys, sorry I couldn't be there in class today. I'm at a district meeting this afternoon, but I'm going to walk you through the Unit 2 quiz critique and retake form on video. So you should have already gotten your quiz back. So why don't you take a minute to answer the reflection questions up here on top, and then also go ahead and write down whether you got the questions right or wrong there in your data table. So if the sub could just pause it for a minute to have students reflect on those 10 questions, then we're going to get started with the answers, and students can then describe what went wrong for each one that they got wrong. All right, first we're going to go over those that had version A of the quiz. So in version A, the first question was to draw a picture of a nitrogen atom. And so if you drew something like this, here on screen, we've got nitrogen in the second row, so he has 2 shells of electrons. He's in column 5A, so that means he's got 5 valence electrons. So 5 electrons on that valence shell, that outermost shell there. And then in the middle, you should have indicated what's in the nucleus. So we've got 7 protons because that's nitrogen's atomic number. And then we also have 7 neutrons too, because the mass of nitrogen is 14, and 14 minus 7 protons is going to leave you 7 neutrons. So that's what your picture of nitrogen should have looked like for 1A. Now 1B asked, is nitrogen a metal or a nonmetal? And nitrogen is on that right-hand side of the staircase, so he's in the nonmetal part of the periodic table. In 1C, it asked if nitrogen was bigger or smaller in size compared to fluorine. And because nitrogen comes before fluorine as you go from left to right on the periodic table, nitrogen is actually going to be bigger than fluorine. Because remember, size decreases as you go across from left to right. So it gets smaller as you go to the right. So nitrogen is going to be bigger than fluorine. In 1D, it asked, does nitrogen have a stronger or weaker Coulombic attraction compared to beryllium? If you look on your periodic table, beryllium's way on that left-hand side versus nitrogen on that right-hand side. So nitrogen is going to be stronger in Coulombic attraction than beryllium. Nitrogen has more protons in its nucleus and is on that right-hand side. So it's definitely stronger. In 1E, it asks if nitrogen has a high or low electronegativity compared to lithium. So again, lithium is even further left on that periodic table. And remember, electronegativity is how attractive those atoms are to other electrons. And those guys on the left are very, very low in electronegativity. Electronegativity increases going to the right there on the periodic table. So nitrogen will definitely have a higher electronegativity than lithium. In 1F, it asks if nitrogen has higher or lower ionization energy compared to phosphorus. In this case, phosphorus is 1 down, okay, in the column. If you look at your periodic table, it's 1 down in the column. And so remember, as it goes down, the ionization energy decreases. So that means nitrogen has a slightly bigger or more ionization energy. It's going to take more energy to remove an electron from nitrogen than it is from phosphorus. In 1G, it asks how many valence electrons does nitrogen have? Well, if you drew your picture correct for 1A, you're going to see your 5 valence electrons. So nitrogen has 5 valence electrons. And remember, he's on that side, that right-hand side, that's very attractive and very strong. And so instead of losing, he's going to be gaining electrons. Now, next to it, you should have said gain 3, but we kind of just went over that the class before, and so I'm giving people a little bit of grace. As long as you said gain, because you understand that they're going to, they're very attractive on that side, on that right-hand side, then you got the points. If you actually wrote down the correct number of electrons that he is going to gain, then you see a little +1 next to that. And so you got a little extra credit point for understanding that it's going to gain 3 more in order to get a full valence shell of 8. Now, when it has a full valence shell of 8, That means we're going to be able to answer question I, which says, which noble gas will nitrogen now have the same amount of electrons as? So if nitrogen begins with 7, he adds 3 more because he's going to take those 3 from other atoms in order to get his full valence shell. Then he's got a total of 10 electrons. And if you look at the periodic table, the only guy with naturally 10 electrons is neon. So 1I, the correct answer is neon. Now again, I gave you that was a little extra credit point for that one as well, because we really hadn't talked about it until after the quiz. And then last but not least is letter J. And letter J is asking, what is the resulting electrical charge on neon? Or, I'm sorry, not neon, nitrogen. So you know if it gains, it's going to have more electrons than protons. And so a negative charge is what we were looking for there. All right, so if you have any questions about any of the answers to version A, please make sure that you come in to see me tomorrow at break, lunch, or before school, and so you can get those answered before our test next class. All right, now let's take a look at version B. So if you had version B, you started with drawing a model of oxygen. Oxygen is in that second shell, just like nitrogen. And so he's got, second row, just like nitrogen. And so he's got 2 electron shells, just like nitrogen does. And he's in row 6A, so that means he has 6 valence electrons. And so we can see that in our 6 valence electrons, 2, 4, 5, 6 on that outer shell. He's got 8 total electrons to balance out those protons in the middle, so that's why we've got 2 electrons on that inner shell. Now in the nucleus we've got 8 protons because oxygen is number 8 on the periodic table. And if we take the mass and we subtract the number of protons, we'll find out that he also has 8 neutrons as well. So that's what your picture should have looked like for oxygen. Now the rest are similar questions, just like version A. So let's take a look through. For 1A, it says, is oxygen a metal or a nonmetal? So just like nitrogen on that right-hand side of the staircase, he's a nonmetal. Is oxygen bigger or smaller in atomic size than carbon? On the periodic table, it goes carbon, oxygen, nitrogen. Nope, just kidding. It goes carbon, nitrogen, oxygen, fluorine. So we can see that oxygen is more to the right than carbon. So carbon is going to be bigger, and oxygen is going to be smaller. Because remember, as we go from left to right on the periodic table, size decreases. That means it gets smaller as you go towards the right. So 1C should have been smaller. 1D, does oxygen have stronger or weaker Coulombic attraction than fluorine? So we can take a look on our periodic table. Fluorine is right next door to oxygen, but he is going to definitely be stronger. Fluorine's going to be stronger. So oxygen is going to have a weaker Coulombic attraction. 1E says, does oxygen have high or low electronegativity compared to selenium? Selenium is 2 rows down in that column of oxygen. And so because going down a column, the electronegativity decreases, then oxygen is actually going to have a higher electronegativity than selenium. In 1F, it asks, does oxygen have a high or low ionization energy compared to beryllium? Well, beryllium's way over on that left-hand side of the periodic table, where it's the weaker side, the one that has less attraction. So using our periodic table trends, we know as we go from left to right on that periodic table, that ionization energy increases. So oxygen will have a higher ionization energy than beryllium. If you drew your picture correct for 1A, you know that oxygen has 6 valence electrons. Remember, you look at the group A number on the periodic table. Okay, to find that. So oxygen's in 6A, so we have 6 valence electrons. Now, we just explored oxygen on that right-hand side, belonging to the really attractive and much more stronger atoms than the left-hand side. So that means he's going to gain electrons. He'll gain 2 in particular. So again, if you identify 2 correctly, you got a little bonus point there. And then just like nitrogen, he's going to gain electrons in order to get 8, like that nearest noble gas, which is neon. So 1I is neon. And then last but not least, 1J, the resulting electric charge on oxygen. Well, if he gains electrons, now he's got more more electrons than protons. And so with more electrons comes a negative charge. All right, again, just as those who had version A, if you had version B and you're really confused on any of these, please, please, please come see me tomorrow before school at 7 a.m. or at break or at your lunch to get any clarification before your test next class. Again, remember, we have a unit test next class on Thursday. All right, last but not least, let's take a look at version C. So if you had version C, then you had to draw the sodium atom. And sodium is in that 3rd row. And so he has 3 electron shells. And so you can see in our picture, there's 3 shells or 3 rings for electrons. Sodium is in group 1A, so that means he has 1 valence electron. And so we can see that there in that very outer shell. And then that means his other 10 electrons are in that first and second shell. The first shell always holds 2, and that second shell always holds 8. So we can see there we've got 2 in the first, 8 in the second, and 1 in the valence shell to make his total of 11 electrons. Now in the nucleus, those 11 electrons have to be balanced by 11 protons. And for sodium, he's actually going to have 12 neutrons. The mass for sodium is 22.99, which rounds up to 23. And if we do the math, 23 minus 11 protons means that there's 12 neutrons left over. Okay, so he's going to have 12 neutrons in the nucleus. All right, unlike nitrogen and oxygen, we can see that sodium is on the left-hand side of the staircase, and so he's a metal atom. And he is going to be bigger in size than phosphorus. So sodium's over here, phosphorus is over here. Remember, size decreases, so it gets smaller. So that means that sodium is going to be bigger, right? And phosphorus is going to be smaller. So sodium is going to be bigger than phosphorus. 1D says, does sodium have stronger or weaker Coulombic attraction compared to chlorine? All right, so again, chlorine's on that right-hand side of the periodic table. And we know from our periodic table trends that Coulombic attraction increases going across. So that means sodium is going to be weaker on that left-hand side. 1E, does sodium have high or low electronegativity compared to sulfur? Again, sulfur is also on that right-hand side of the periodic table. And so he is going to be, sodium is going to be lower in electronegativity. He's not going to be attracted to electrons. It follows that same trend as Coulombic attraction, where it's strong on the right-hand side, but weak on that left-hand side. 1F asked if sodium has high or low ionization energy compared to rubidium. Now, if we take a look at our periodic table, sodium is in group 1A along with rubidium, but rubidium is much lower on the periodic table in that group. And so as you go down, the ionization energy decreases. So that means it's much easier to take away electrons from rubidium. And it's going to be a little harder to take away electrons from sodium. So sodium has a higher ionization energy. For 1G, if you got your picture right in 1A, then you know that sodium has one valence electron. And because he's on that weaker side, he's going to lose that one valence electron. And again, just like the other ones, if he has 11 to start with and he loses one, that means he's going to have 10 electrons left over, which matches our neon noble gas. All right, if we lose an electron, that means we've got more protons than electrons, and so 1J is positive. Positive 1 charge is what sodium is going to be after he loses his electron. All right, so just like all the other ones, if you had version C and you have any questions about any of these quiz questions or answers, please come see me tomorrow before school at 7 a.m. at break or at your lunch. So you can get your questions answered before the test on Thursday. All right, so last but not least, taking a look back at your retake form. If you don't like the score that you got, if it's not what you expected, or if you know you can do better, then you have a chance to retake it. But the deadline for retake is on Friday, okay? We are heading towards the end of the semester, which means we don't have a week or two in order to study for this stuff. You've got a couple of days. So if you are planning to retake it, you need to make sure that you follow the directions in steps steps 11 through 13. So you need to print 3 copies of that retake form that you're going to find on Haiku. And you need to watch videos and do practice problems for all 3 of the topics that were included in the quiz: parts of the atom, periodic table trends, and ionic bonding. Okay, so once you have all 3 of those papers filled out, front and back, with the notes and practice problems, then you can come in by Friday. So Friday at second lunch is the last day to do this. To come in and retake this quiz. All right, so you do need to make sure that you get your parent's signature, and then I will sign you off once you have all of that stuff ready to go and stapled to this test critique. All right, so go ahead and keep this quiz, keep this test critique, and if you want to retake it, then you're more than welcome. One last thing, though, is for the CER. You also, if you did not do well in the CER, you can redo the CER by Friday as well. What you'll need to do is just take a look at your checklist. All the things that have a little dash or a circle because it's missing and I couldn't find it in your CER, make sure that you understand what went wrong, and then you can come in on 8 days before school at 7 a.m. You can come in at your lunch Wednesday, Thursday, Friday this week. Or if you let me know in advance, you can come in on Wednesday and Thursday after school during tutoring hours to redo the CER as well for better points. So you also have a redo for the CER by Friday as well. But again, we've got a tight deadline for the end of the semester.